Hi guys, so I've been kind of wanting to get back into MCAT studying. I'm planning to take a gap year, so my MCAT is kind of pushed. I haven't been doing much, but I think it would just be good to just be doing things in the background. So like instead of having like a perfect study plan, just like repeating and recycling, going over the material, that repetition will just kind of help me out. And so right now I'm just gonna kind of design a study plan. So fall 2025 is already kind of busy for me, so I think the game plan is, okay, let's move all this. I know we said Anki cards, but I'm actually going to move that too. I realize Anki is only good for memorization, not for learning concepts like thoroughly. And so my game plan is more so going to be, is doing, okay, Khan Academy to build that repetition. And then I think for more like structured, I could be going through the Princeton books. And I want to set more realistic goals for myself. So I'm taking an MCAT neuroscience class this semester. So I guess it would be reasonable to go through like the neuroscience section and also go through biology a bit and biochemistry since I'm taking that course. So I'm going to first of all put biochemistry since we're doing a lot of that this semester. Look at me overloading myself. Biochemistry, biolab, because I'm taking biolab as well. Like, lab methods. Okay, maybe I'll leave it to these two. If I want to do like the neuroscience, like I don't think I should include neuroscience stuff. I think that would overwhelm me. So I'll just stick to these two concepts. And I guess as I'm doing this so biochemistry, specifically to go about it structured, would be kind of going through maybe making Anki cards for like amino acids. Okay, maybe if not Anki cards, maybe cheat sheets for like things I need to memorize. So I'll write here Anki or cheat sheets for stuff to memorize. And then just going through the lessons and books in a like organized manner. Maybe I could make like videos off of them. Make videos. Teach aloud. Or maybe just like repeat, like repetition is the idea. And then for biolab, I guess I could also do the same thing of making like Anki or cheat sheets with the stuff to memorize. Also have all information in one page. All info in one page. But also I don't want to waste too much time on taking notes. Yeah, and I want to make sure I'm going through the books. Going through... Okay. The lessons and the books. Because I'm taking biochem and biolab this semester, so I might as well kind of have that in the background. I don't think we'll have a routine, but my goal is to do like 30-minute daily. If not, okay, 30 minutes is kind of a lot. Maybe I'll like lower it to 15 minutes. So how about I build like little like check-in sheet. So fall 2025. Let's start in the month of October. So let's just do it like this. October. So my goal is gonna be daily 15 minutes. Keep it realistic. Okay. And so today is the 7th. It's a Tuesday. And then I can like write down what I did, and then after I'm done, I'll just like highlight it. So let's go 7th is the Tuesday, 8th is a Wednesday, okay, 9th is kind of a busy day, and then 10th is a Friday. Okay, and now not to waste too much time, I think today we will do more Khan Academy. And so the idea with Khan Academy is I will be going through the foundations in order. So let me write that. So I remember. Low-key, I also don't need to be writing that, because I think if I write, okay, I won't write that because then it might overwhelm me. So for Khan Academy, I'm just going to go to the foundations and structure and take notes as I kind of go through that lesson. Okay, so I think that is kind of the game plan. I'll write myself a little date. Okay, so we already did these questions. I mean, okay, let's do these questions. It doesn't hurt. Which of the following? Okay. Ooh, okay, negative anything acidic. So glutamic acid. Ooh, okay, I always get this question wrong. Okay, I think it's, okay, so S is sinister. R is right. I know a lot of things have right configurations. Okay, I don't know what this is. The amino acids, hemoglobin, or any protein you have which of the following configurations. Is it S? But I thought sugars were all S. Okay, no, sugars are all D. So is it L? Okay, I did not know this, so let's kind of review this. Okay. The amino acids in hemoglobin or any protein you have which of the following configurations. So configurations are either relative or absolute in amino acids refer to the stereochemical configuration around the chiral carbon. So I need to go through OChem because I don't remember this. Due to differences in the priority of different amino acid side chains, not all amino acids have the same absolute configuration, which refers to the RS naming convention. Some amino acids are R and some are S. The relative configuration, or the LD configuration system, is used to describe the stereochemistry of amino acids and sugar based on their structural relationship to the reference molecule glycerolaldehyde. Is that a lipid or something? Okay, the L form of glycerolaldehyde. Okay. And the same. Whoa, I'm not understanding any of this, to be honest with you guys. So here we have, okay, so something is L if the amino group is positioned on the left side. Okay, so this is an L amino acid because when you look at it, the amino acid is on the left side. And this is a D because the amino acids is not. So LD go together. All amino acids have the same relative configuration, which refers to the DL naming convention. All biologically produced amino acids are in the L configuration. This means that you would refer to the biologically produced amino acids L-glycine, L-alanine. So that's why it's L. Okay, so we said RS has to do with chirality, so okay, so not all, okay. And then L amino acids have to do more so with, okay, I'm gonna take a screenshot of this question. Done. Okay. See, we are learning. Okay, let me write the title. Amino and protein questions. Okay, so over here, okay, I don't remember what D. Okay. What is RS? It's the can include rules describe the absolute. Okay. Okay. So you assign priorities on 4 different groups. Okay. So you assign it so that we're going clockwise. You assign priorities and the priorities. Okay, I literally don't remember the rules. Okay. Find the tetrahedral atom, assign priorities, the SIP rules, give priority 1 to the group attached to the crowd. Okay. You want to orient the lowest small priority group away, and then if it's away, then you go R and S. Okay, so how does this relate to proteins? Because I think do all proteins have same stereochemistry, R and S? I think they do, because they're considered out, except for glycine, have cryosensors that can be either R or S. Though L amino acids are overwhelming, the S enantiomer, which is amino. I'm not gonna lie, I'm not understanding any of this stuff. It's been so long, my OChem is weak. Okay, so I'm gonna screenshot the little answer key. Unfortunately, I don't even think I'm gonna be able to go through all the questions like I would like. But the key today is that we are more so focused on spending that daily 15 minutes of even looking through the questions, so it's a win. Okay. I think it's also problematic that I go through these questions in so much depth that I'm not able to do it daily. Okay. So the answer we have, okay, so the takeaway I think I should remember is that we have all biologically produced amino acids are in the L configuration. Okay, I'll remember that. And the L has to do with this NH2 being on the left side. Okay. Left side. As for the RS, so this has to do more with chirality. So, okay, so chiral center is either R or S. So R is right, S is left, based on CIP priority rules. Okay, this is my takeaway. I will keep this in my head. Let's see the next question. Which of the following protein properties are least likely to be affected by the pH? Okay, net charge definitely is going to be affected by pH. Tertiary, secondary, I'm going to say primary structure, because tertiary structure and secondary structure, they all bind based on the charges and the affinities of these different bonds, whereas the primary structure's peptide bonds are more so the N and C. I don't know how to explain it, but this is primary structure. Let me see. Is the amino acid sequence of a protein plus the peptide bond joining together, it changes unlike to at least. Okay, yeah, I'm just gonna go through with this. Hydrogen bonding between separate subunits of DNA polymerase, example of which of the following? DNA polymerase. So this DNA polymerase is a protein. We're looking at hydrogen bonding.